Hello class, this video is on Knights and Knaves puzzles. Hopefully you've already watched the video of the movie Labyrinth where the character Sarah tries to figure out which of the two doors to go through. This class will teach you some important life lessons like how to escape from a labyrinth governed by the Goblin King David Bowie if you ever found yourselves transported back into the 1980s. How did Sarah figure out how to solve that riddle so quickly? Here's the way to work it out in truth functional logic, because we can explain what was going on in that riddle just in terms of truth functions. Let's use some abbreviations. I'm going to use D1 to just represent the idea that door number 1 leads to safety. So D1 is an atomic sentence. It could be true or false. Now let's define two truth functions. One truth function T here is the person who always speaks truly, and truth function F is a person who always lies. So if you ask T whether D1 leads to safety, they would say yes when it's true, and they would say no, or it's false when it's false. The person who always lies just inverts those truth functions. So notice that F, this is really an abbreviation for negation, and T, you could think of this as an abbreviation for double negation if you wanted, or just anything else that is equivalent to the original sentence. Now, what's so tricky about the question that Sarah asks is, what would the other person say? Now, so what's nice is, it doesn't matter if the person you happen to ask that is speaking truly and the other person is speaking falsely, or if the person you ask it to is speaking falsely and the other one is speaking truly. It turns out that those two things are going to be equivalent. So that's how she can know whatever that person says, she should go through the other door. So we can simply explain what's going on in that case in terms of truth functions. Now this solution only works because she knows that one of the guards speaks truly and one always speaks falsely. We can make the puzzles a little bit harder by putting it in this form, which is due famously to a logician named Raymond Smullyan. We can talk about the island of knights and knaves as this fictitious place where knights always tell the truth and knaves always lie. Now you might run into some people from the island of knights and knaves, like two guards, and in this case there's lots of knights and there's lots of knaves, so you don't get to know that one of the people is a knight and the other one is a knave. Maybe both of them are knights, or maybe both of them are knaves, so you have, strictly speaking, less information to work with in this kind of generalizations of the puzzles, but nonetheless you can still figure out which door to go to. For example, consider this. Let's say that you meet three guards. All three of them you know are either knights or knaves. By which I mean, you know guard 1 is a knight or knave, you know guard 2 is a knight or knave, you know guard 3 is a knight or knave. You don't know that they're all knights or all knaves, and you don't know that there has to be at least one of each or whatever. You just have to reason from the information that you do have. So, pause your videos here and see if you can figure out how that reasoning would go. Okay, I don't want to ruin it for you, so really you need to pause your videos and try to think through this. It's quite fun. Now, if you still haven't paused your videos because you need a hint, here's my hint. The proofs of these actually go by disjunctions. You know the following. You know guard 1 is a knight or knave. You don't know which, but you at least know that disjunction is true, so you could do proof by cases on it. Similarly, maybe you could just start with guard 2, and you could say guard 2 is either a knight or knave, and you could work from that disjunction. You can start at any of the guards, but for simplicity, let's just start at guard 1. So let's imagine that guard 1 is a knight, so this is like case number 1 in our proof by cases. Then, if guard is a knight, then number 2, so what the guard says here has to be true. So I'm thinking about it like this. If they're a knight, they must be speaking truly, so guard number 2 must also tell the truth. So that's like an additional consequence of case number 1. Now, if guard 2 is telling the truth, they're also a knight, then number 1 and number 3 must speak the same. Given that number 1 is a knight and always speaks the truth, number 3 must always speak the truth. So, given that guard 3 says door number 2 is the way out, according to case 1, door number 2 is indeed the way out. Now, we don't know yet that's true. We still have to consider what's going on in case 2. What if guard number 1 is a knave and is speaking falsely? Well, if that's the case, then they're a knave. Then it's false that guard number 2 speaks the truth. So guard number 2 must also be a knave. So in case number 2, guard 1 and 2 are both knaves. Now, guard number 2 says 1 and 3 speak the same. 1 is a knave, remember. But if that is false, because guard number 2 is a knave, remember, then 3 must not be a knave. 3 must be a knight. Well, isn't that interesting? Even in case number 2, guard number 3 must be a knight. So we know the information contained in here means that guard number 3 is a knight no matter what. And therefore, door number 2 is the way out. So, hey, we'd be saved here. We'd go through door number 2. Okay, and now that you see how that reasoning goes, hopefully you can employ it yourselves. So, let me give you another puzzle. The same setup as before. We have two guards here. You don't know if they're both knights or knaves or whatever. You just use that disjunctive reasoning to try to figure out which way you should go. So again, let me give you a minute to pause your videos here. Okay. I'm going to start with guard number 1 again, but that's just for convenience. There's nothing that says you have to start thinking about it in those terms. So I'm going to think, what if guard number 1 is a knight again? Then this disjunction, the guard number 1 says a wide scope or claim. So I don't yet know that I know the or claim is true. So I don't know if the antecedent or consequent are both, excuse me, if the first disjunct or the second disjunct is true, or both of them are true, but I have to figure out which. So let's consider the first disjunct. Could this be true? Well, the first disjunct is that I speak falsely, but guard number 1 is a knight, so he could never speak that falsely. So that he could never say I speak falsely truly. So he could never actually say that as a knight and have it be true. So this disjunct is false. So what about disjunct number 2 then? This would have to be true if guard number 1 is a knight. So if guard number 1 is a knight, then guard number 2 is a knight too, because that disjunction must be true. So door number 1 must be the way out. Okay, so that's just case number 1. We would go through door number 1. Now let's consider the possibility that guard number 1 is actually lying. This case is more interesting because guard number 1 says a disjunction. In order for it to be false, both disjuncts have to be false. So I speak falsely would have to be false. In order for I speak falsely to be false, he would have to be a knight and actually speak truly. But he's not a knight, so this couldn't possibly be false. So we actually get a contradiction. Case number 2 is impossible. It's incoherent. And that's how we know that guard number 1 could not possibly be a knave. Only a knight could say such a thing. It's unspeakable by a knave. So therefore, door number 1 is indeed the way out. Okay, there's some fun knights and knaves puzzles.